So, oh, this is not quite review number 14. I'm just using this thing as an example. We wanted to remember how to find maxes or mins locally. So, to find a max or a min locally, the idea is it should be flat there, right? This is telling you the change in the
X direction.
The I direction.
yeah, in the x direction, right? And the change in the t direction is given by the other portion of the gradient.
And that would be I and J, right?
Yeah, so that's what I would call I and J in this case, right? Of course, they mean a slightly different thing than usual because I'm talking about an S and a T axis instead of an X and Y, but yeah, I'd call them I and J. So if I want a flat spot, right, it's got to be flat in both directions. Okay, so let me set both of these equal to 0 and see what I can get. That's really setting the gradient vector equal to the 0 vector, right? Solving. So I've got minus t squared plus 2t plus 4 over 2s to the 3 halves is 0.
Minus
and
4.
Oops, minus 4, thank you. And 1 over the square root of s times 2t minus 2 is 0. And I need both of these to be simultaneously satisfied, right? Okay, so what am I finding out of this first one?
S can be 0.
Okay, yeah, so there's problems when s is 0. I better worry about that, so I'm just going to kind of highlight that object for later. What else you got there? Yeah, fraction 0, right, when the top is 0.
Yeah.
So I've got t squared minus 2t plus 4 is 0.
Minus 4.
I switched the signs
Oh,
the
you
whole
switched
time.
the signs. Oh.
Nice try.
Dang it.
Okay, and then can I factor this?
No.
Yeah.
Yeah.
Well, maybe with the quadratic, but no.
You can
No,
complete
not-
this.
not
complete
the
square.
actual factor.
I can complete the square? Okay, so t squared minus 2t plus is negative 4. So I need a plus 4.
Plus 1.
1. Or add 1 to both sides.
Yep.
Okay. So I got t minus 1 squared equals negative 3.
Ooh, can't do
Shit.
Okay, there aren't any of those.
Yep.
So do I need to bother with the other one?
No. Do you?
No, because they both have to be 0, right? There aren't any zeros for the left-hand thing, right?
Yeah.
In other words, this is either what? Like
So-
interpret in terms of a derivative. What did I just find out? I found out that this guy's never 0. What was this guy? It's the first component of the gradient vector.
The
The slopes in the
Yes.
S direction.
The slope's in the s direction. I found out the slope in the s direction is never flat.
Okay.
You guys see
It's
that?
always negative.
So I'd say it's either always negative or positive, except that I've got this
Well, it's the negative
That's
t squared.
this
so
thing
it's
highlighted.
You
You see
can't
that?
say what it is, it just gets weird.
Yeah, so it's never 0 at any rate,
Yeah.
right? So it's on chunks either positive or negative, and there's a discontinuity on the s-axis, or sorry, the t-axis where it might switch. Okay, see that? So either way, it's never flat in that direction, so it definitely doesn't have a local maximum.
Okay.
Cool. Global max or min might be a different story.